In this video, we'll be looking into designing a DFA to accept string of zeros and ones ending with 0, 1. So let's write what are the strings, that is sigma is equal to 0 and 1, and it has to end with 0, 1. So our first step would be to write the language here. So L is equal to, it should end with 0, 1. In the starting there could be nothing, that is minimum 0 and 1, or 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, and so on. So all these languages are accepted because they are ending with 0, 1. So our next step is to write the regular expression. This is our first step. We have to write the regular expression. So see, it could start with anything 0 or 1, but it has to end with 0, 1 only. So that's how we can write 0 plus 1 star 0, 1. So this can be further written as lambda into 0, 1. Lambda has no value, so 0, 1. So the 0, 1 would be the W min. So here W min is 2 digits or 2 strings. So the total number of states would be 2 plus 1, that is 3. So our next step is to design the initial finite automata. Design initial finite automata. So 3 steps as they have said. So the first state would be the initial state, followed by one intermediate state, and then the final state. So 0 and 1 accordingly as given in the question. So our next step is to find transitions of all sigma values for each state. So here if we see, we know 0 on Q0 on 0 is Q1, but Q0 on 1 is unknown. So we have to find transition of Q1, Q0 on 1 firstly. Then we have to find transition of Q1 on 0. Then we have to find transition of Q2 on 0 and transition of Q2 on 1 as well. So first let's start with Q0 on 1. Q0 on 1. So Q0 on 1. So first let's write 1 here and 0, 1 followed by that. If we notice, we can understand that Q0 on 1 we have to know. Here Q0 on 0 is defined as Q1. So here Q0 on 0 is defined as Q1 and Q1 on 1 is defined as Q2. So it is starting from Q0 and ending with Q2. That is initial DFA. Now we have to find the link of Q0 on 1. So there's only one possible transition, that is Q0 on 1 should go to Q0 only. I hope you have understood this step. So only this would be accepted. Thus transition of Q0 on 1 is Q0 only. Similarly Q1 on 0, Q1 on 0. So before Q1 we have 0 here. Let's write 0 here. Q1 on 0 is unknown. So let's write 0 here and let's write 1 here. So previously 101 was in the language which could be accepted. Here also 001 is also acceptable. So here it has to start with Q0 and this Q1 on 0 is what we are dealing with, right? So here it has to start with Q1. Q1 on 0 is unknown. Q1 on 0 is unknown, but then Q1 on 1 will give Q2. So the only possible way is Q0 on 0 is Q1. So Q1 on 1 the only possible way is Q1 on 0 should give Q1 itself. So that's when this state would be accepted. Thus, transition of Q1 on 0 should be Q1. And next is Q2 on 0. So before Q2 we have 0 and 1. So let's write 0, 1. And on Q2 what should we find? 0, right? Let's write 0 here. Is 0, 1, 0 falling under the languages, under the language set which we have written? No. Because it has to end with 0, 1. Here it is ending with 1, 0. So let's add 1 here. Now here we have to start with Q0. Q0 on 0 gives Q1. Q1 on 1 gives Q2. Now we have to find Q2 on 0. So Q2 on 0 gives what? We don't know. Right. But here Q1 on 1 gives Q2. I hope you have understood this. So the only possible way is Q2 on 0 should give Q1. Thus, transition of Q2 on 0 should give Q1. Next we have Q2 on 1. So let's write 0, 1. Before Q2 we have 0, 1 and here 1. So does 0, 1, 1 fall under the language set? No, because it has to end with 0, 1, right? So let's add 0 and 1 here. So we know that Q0 on 0 gives Q1 and Q1 on 1 gives Q2. Now we have to find Q2 on 1. So Q2 on 1 gives what? We don't know. But 0 and 1 is there here. So if 0 is there, it has to start with Q0 only. Thus, let's write Q0 here. Q0 on 0 gives Q1, Q1 on 1 gives Q2. So the only possible transition could be Q2 on 1 should give Q0. So I hope you have understood this step. Transition of Q2 on 1 should give Q0. So in this way, we have found out the transition states of all the sigma values. So our next step would be to write the step 4 would be to design the DFA. As we know all the transition values, transition states, we can write the DFA. So let's write the initial finite automata as it is, that is Q0 here, Q1 here, and Q2 being the finite state, final state, here 0 and 1. So now let's, whatever the transitions we have found here, let's write it on the DFA. So Q0 on 1 gives Q0, fine. Q1 on 0 gives Q1, fine. Q2 on 0 gives Q1, fine. And Q2 on 1 should give Q0. So this is the DFA which we have designed. Now let's define the DFA. Step 5 would be MD is equal to Q sigma Q0 F, where we know that Q is all the states which are being considered in the DFA, that is Q0, Q1 and Q2. Then we have sigma, that is the strings which have been used, other words, that is 0 and 1. And all the transitions have been defined in step 3. Q0 is the initial state. Initial state here is Q0 itself. And F being the final state or the accepted state, here it is Q2. So our next step would be to consider two strings, one for acceptance and other for rejection, and show sequence of moves made by the DFA designed in the step 4. So let's take first word, that is 1 0 1 0 1. It is ending with 0 1, so we know that this word has to be accepted. Similarly, let's take another word 0 0 1 0 1 1. It is ending with 1 1, so this has to be rejected. So let's show it here. So first it has to start with Q0, initial state. Q0 on 1 is Q0 itself. Q naught on 0 is Q1. Q1 on 1 is Q2. Q2 on 0 is Q1, and Q1 on 1 is again Q2. So it is same as the initial state, and the final state is also same as defined above. Here let's start with Q0 on 0 gives Q1, Q1 on 0 gives Q1, Q1 on 1 gives Q2, Q2 on 0 gives Q1, Q1 on 1 gives Q2, and Q1 on 1 gives Q2. Q2 on 1 should give Q0, sorry. So here, though the initial state is same, but the final state is not Q2. Thus this is rejected, and this word is accepted. So we have shown an example as well. One more step is there to draw the transition diagram, or let's say transition table of the DFA which we have obtained, which is DFA. Here let's write the sigma values, that is 0 and 1, and on this side we have to write Q0, Q1 and Q2. Q0 being the initial state, let's represent it with an arrow, and Q2 being the final state, let's represent it by a star. Q0 on 0 is Q1, here Q0, Q1, Q2, Q1 and Q0. So I hope you have understood how to design a DFA with a given condition. If you have any doubts, do let me know in the comments, and subscribe to my channel. Thank you.